Hello friends, welcome back. In the previous tutorial, we have learned how to overload the binary plus operator, how to overload unary minus operator, how to overload binary minus operator. Now in this tutorial, we are going to understand how do we use the unary operator minus and what is the importance of it. The minus operator is negating the vector here. You can see that. You can understand what happens. Let us understand step by step. Here I create a vector 2D position vector which is equal to new vector 2D, and x is equal to 100.0f, y is equal to 100.0f. This indicates that my game object is at 100. Let us take an example here. Now let us take the game object is present over here, right? So the velocity, the position vector looks something like this. We know that, right guys? We know already it looks something like this. Of course, this indicates the position vector. Let us say it is P vector, right? Somebody said that, okay, at present the game object is at 100, that is the position, and it is moving in the right direction at a 100 velocity, you can say. So I need to create a velocity vector, right? So I create a vector 2D with the name velocity, V-E-L-O-C-I-T-Y. Velocity vector is equal to new vector 2D, x is equal to 100.0f, y is equal to 0.0f. That means it is not moving in a y direction, it is only moving in a x direction. And we also know that how do we represent that vector, guys? We represent that vector from the origin. We draw a line something like this, right? And this vector is going to be the velocity vector, that is going to be a v vector. And of course the x is 100 here, y is 100 here, right? Now what we want to do, we want to move it in this direction, right side. I need to add the v vector to the p vector so that I get the resultant vector and apply that to the position so that I can move the game object from one place to another place. What I do then, I need to write a code for that. Simply I say here, position vector is equal to, take the current position, add the velocity to it, and assign that resultant vector to the position vector so that the game object moves to the next step. Now what happens here, guys? We know that what happens here behind the scene. I can say that the velocity vector, if we arrange in the tail and head format, it looks something like this, right guys? We are going to find the velocity vector over here, that is the v vector. At present the v vector is looking in this direction, so our game object will be over here. Its x position at present, before adding, x is equal to 100, x is equal to 100 and y is equal to 100, that is the position vector before adding the velocity vector. Then now what happens, guys? We know that it is going to become 200x, y will be 100 only. So our game object will be over here. So new position, the new position vector is going to be looking like this. It looks something like this, guys. That is going to be our new position vector, which is actually the sum of p and v. This is the new position vector. That means if I display now, the position of the game object should be 200, 100. We can see that it is very simple to see. I just need to say debug.log and display the position.x plus double quotation plus position.y. It just displays the x and y of the game object position. Now let us save and run and check in Unity. So it is saving now and compiling for any errors. There are no errors, and if I run the code, you should see here 200, 100 on the screen. You can see that we have position is 200, 100. Interesting. Now I can add one more time. I can say the new position should be, take the current position, add again the velocity to it one more time. If I do, what happens? We know that very well, guys, right? What happens here? The current position is 200 and 100. If we add the velocity again to the position, our game object is going to move to this place. Correct or not? It will be over here, and the new position vector is going to look something like this. Right? So what will be the x and y value over here for the position, guys? The position dot x will be 300 and the y will be 100 as it is. Right, guys? You can see that. I just save it. I come back over here and you can see I just copy this and I paste here down. You should see here 300, 100 now. Let us save. You think now you are just adding again and again the velocity to the current position so that you can move the game object. Let us save and come back to Unity and run the code. You can see that 300, 100. At present the game object is at 300, 100. So if I add one more time, I can copy this, I can paste it down. You can say me what will be the next position, guys. You can predict very easily, right? So x will be 400, y will be 100. That means the current position is this vector, that is 300, 100. If I add the velocity to it, the new game object position will be here, and that will be having the x 400 and y 100, guys. I hope you guys are understanding what is actually the meaning of the velocity vector. This is actually from physics, right, guys? What is velocity? Rate of change of position, right? You can think like every frame you are moving, you are changing the position. Rate of change of position, you can say over time. The position of our game object will be 400 and 100. So this is our v vector we are adding, and this is the latest position vector 400, 100. Let us see that so that you get an idea. You should see here 400, 100. Now here is the important part, guys. You are moving the game object in this direction, that is towards right. Somebody suddenly told that, man, what you do now, move your game object towards left now. I want you to move towards left. Now how do we do that? This is a place where you are going to use the negation operator. Minus. You need to flip your velocity vector so that it should start moving towards left. Understanding? Now let us see that. What I need to do means I need to flip the velocity vector. So if I need to flip the velocity vector, what we need means we take the velocity vector should be equal to minus velocity. Now here you should understand, guys. You are taking the current velocity, that is 100, 0, and you are giving it to the negation operator. What negation operator does, you can see that it makes its components negative, right? You can think like you are giving the velocity 100 and 0 over here, and a dot x minus, if you make it becomes minus 100, a dot y becomes minus 0, and it returns that vector back to us in this place, and that vector has the value minus 100 and 0, and then you copy to this velocity vector. Then what this velocity vector becomes? It becomes minus 100 minus 0, right? I hope you guys are understanding. Now how it looks, guys, after executing this line, the velocity vector looks something like this. Let me take some other color. The velocity vector is going to be minus 100 and 0. This is how it looks, my friends. This is our negative v minus v vector. Now if you apply this vector to the current position, this is our current position, right, guys? The p vector, right? 400 and 100. If you apply this minus v vector, that means if you add the p vector and the v vector, now you are going to get the resultant position something like this. You have a vector which is already negated, minus 100 and 100, that is our new vector, you can say. I just write only v vector because the current vector has the x value minus 100, y value 0. Let me show that one so that you can understand. I can copy this line and paste it down over here just to show you that what is the velocity vector at present. So our velocity dot x should be minus 100, y should be 0. Let us save and come back to Unity just to check that how it is working. And you should see here the last output should be minus 100 and 0, guys. Can you see that you have flipped the velocity vector? So for flipping purpose, you are going to use the negation operator. It is something like multiply by -1 minus velocity means, but that's okay. We come to multiplication scaling later. I hope you guys have understood. When you negate, how do you negate a vector or flip the vector and how it looks. Okay, now if you add the position and the velocity vector, then you are going to get the resultant vector. Now first of all, I have to arrange the position vector and the velocity vector in the tail and head format. So what happens, guys, it looks something like this. This is your position vector, right? At present, the game object is over here. Its x is 400, y is 100. And if you add the velocity vector, at present it is reversed, guys. So what happens now? Your game object will come over here. That is going to be the new position. So new position of your game object is going to be 300, 100. Understanding, guys? Can you see that? Previously, your game object is used to move in this direction. Now it is moving in this direction. So you can flip the velocity vector to move in another direction. Understanding? So now if I add the p vector, let us add the p vector, that is the position. The position, new position should be the current position plus the current velocity. And if I display now, I can copy this and paste over here. I am not going to show this one because we know already. So I just save it. Here I should get 300 and 100. So let us come back and run and check. You should see here 300, 100, guys. Good. I hope you guys have understanding. It's simple. Now again, if I add, I copy this, I paste it down. Now I'm adding the velocity vector to the position vector. What happens, guys? You know that the current position vector is here, which is having the x value 300, y value 100. And if I add the velocity vector, which is minus 100 and 0, the new position will be this place. That means your game object will be over here. So what should I get? The x should be 200, y should be 100, guys. So let us check it out. I copy this, I paste it down, and the last output should be 200 and 100. Let us see now. If I run the code, you see that you have 200 and 100. Now again I can add the position vector and the velocity vector and display the position x and y. And this time I think you know what will be the next position. Can you tell me, guys? It's very simple, right? You know that. So current position is this position which has the x 200, y 100, and if I add the velocity vector, the negative velocity vector, you know that is negated actually, that will be the new position 100 and 100. That means your game object is back to the position, guys, the previous position, right? Interesting. Now of course I should get here 100, 100. Let us save, run and check. You should see here 100, 100. You can see that we are at 100, 100. I can display this position here also. There is no problem in that because initially position.x is 100, y is 100. Let us save, come back and run the code, you can see that initially your game object was at 100, 100, it has went to 200, 300, 400. You flipped the velocity x. It came back to 300, came back to 200, came back to 100. If you again add the velocity to the position, I think you know what happens. Very simple. I copy this, I paste it over here. This time x is going to become 0, y will be 100. Right guys? I think you know that. Graphically, if I have to show, if I add the velocity to the current position, you should know that the game object will be over here, that is x 100, y 0, that is going to be the new position. So you can see that if I run the code, you should see the result 0, 100 guys. You can see you are moving your game object slowly towards left. If you again add the velocity vector guys, again if you add the velocity vector to the current position, at present the position vector is this one, the current position, and if you add again the velocity vector to it, you should see that your game object moves in the negative direction. Now the game object's x value will be minus 100 and the y value will be 100, right? And the resultant position vector is going to look like this. That is the new game object position. Let me add one more time velocity to position. I copy it, paste it down. I copy this one and paste it down. And let us see now. We should get minus 100 and 100 if I run the code. You can see that the new position is minus 100 and 100 guys. So your game object is moving towards left. Interesting. If you add again, I think you know. Next position will be over here, next position will be over here, next position. So you can use like this. I want to again flip the direction. Somebody told you that I want it to move again towards right. At present, the game object is at minus 100 and 100. I want to move it towards right. That means I have to flip the velocity vector again. So how do you flip guys? Very simple. Take the velocity vector, flip it again. Simple. Now this will flip now. At present the velocity vector is minus 100 and 0. If you flip again, it becomes 100 and 0 guys. So after executing this line, your velocity vector will be back to position. It looks something like this. So here you can see your velocity vector back to 100 and 0. That means if you add the velocity vector to the position vector, what happens guys? You know that your game object, now we are arranging in the head and tail format, tail and head format. Here is the game object. Your game object comes over here. Now let us check it out. So we have flipped the velocity vector. I can add the current velocity to the current position, and if I copy and paste and show you, what should I get the result guys? I should get the value 0, 100. Here x is 0, y is 100. So I should get the last output 0, 100. And you can see 0, 100. Your game object is at 0, 100. Guys, I hope you guys are understanding how to use the minus operator. I can add again position to velocity, velocity to position, and I display the result. I think you know where will be the next position guys, where will be your game object. Of course, it will be over here. That is our new position vector. So you should have x is equal to 100, y is equal to 100. So you can see that the game object is at 100, 100 guys. We started at 100, 100. Then we moved it in the right direction, 200, then 300, then 400. Then we flipped it. It has moved back to 300, 200, 100, 0, minus 100. Then we again flipped. It has moved to 0, then moved to 100. Can you see that? I hope you guys are understanding how you can use the velocity vector to move the game object, use the negation to change the direction of the movement of your game object. Now let us see how the code is working behind the scene. We can put one breakpoint over here, we can put one breakpoint over here. I think subtraction is not necessary, only addition is required for us and the negation is required. And I can put one breakpoint over here. I can come back to Unity and run the code. You can see that we are over here and the locals has the position vector and the velocity vector. Both should be 0, 0. You can see that still we have not created. If I step over, you can see that we have the position vector x is 100, y is 100. The velocity vector is still x 0, y 0. Let us step over. You can see that the velocity vector is 100 and 0. If I display this, we are going to get the x position x will be 100 and y will be 100. That is the current position. Then we are adding the velocity that is going to be, let me select this one just to show you. I think I can show you the velocity vector here and the position vector in that. Here we are, right? X is 100, y is 100, 100 velocity. That's good. If I execute this line, you can see that the position has become 200 and y is still 100. Then we display the x and y, that is 200, 100. You can see that the game object has moved in x 200, right? It has moved 100 unit again. I step over. Now the position is 200, 100. Velocity is 100, 0. So if I add, the position dot x should become 300. Now y should be 100 only. And you can see 300, 100. Let us step over. Now this time x is going to become 400 because 300 plus 100 is going to make it 400. 100 plus 0 will be 100. You can see that 400 and 100 we have. Let us proceed further. Now we are flipping the velocity. It is x 100, so it becomes minus 100. You can see that one. And y is going to be 0. We are going to change this velocity. First, you can see that we have here the velocity vector copied 100 and 0. We are flipping that over here. We are going to flip it minus 100 and 0. That will be returned back. That will be returned back and assigned to our current velocity. Here it returns a new vector with the value minus 100 and 0. That will be copied one by one to the velocity vector. That means you are modifying your original vector, right? Let us step over and you should see now the velocity is minus 100 and 0. Then you can add, the position is at present 400, 100. When you add 400 plus minus 100, you are going to get 300. 100 minus 0 is 100. You can see that 300 and 100. You can display that on the screen. And again, if you are adding 300 plus minus 100 makes the x 200, y 200 only. So let us see that one. We have here 200 and 100. You can see that your game object is moving in another direction. So this is how you can step by step add, move further. Here we are. Now the velocity vector, if you see, now the velocity vector is minus 100 and 0. If I flip it, it becomes 100, it becomes 0. Let us step into first. Yeah, you can see that it has become 100 and 0. Then if you add to the position is minus 100. Minus 100 plus 100 makes it 0. 100 plus 0 is 100. Let us step over. And if you see, the position x is 0, y is 100. This is how the code works, guys. I hope you guys have understood. I just continue and remove these things. You can create a position vector which might looking down, maybe like this. The position vector looks like this, and you can try the velocity vector in this direction and see how the object moves. Or you can try for move yourself an object up and down. So here again you need to flip the velocity vector. You can try. the different ways what you can do. You can try for maybe moving an object in this way diagonally. How do you do that? Just check it out. So this is how you can use the negation operator. Take you have a vector, velocity vector, which looks something like this. This is just an example. The vector is having the value x minus x is 200, x is 200 and y is minus 200. Understanding? Then if you flip, if you negate, how your vector looks? Can you tell me, guys? X is going to be minus 200, so that is over here. Y is going to be 200, that is going to be over here. That means if you flip your velocity vector, it looks like this, guys. You are flipping the x as well as y components, so definitely the resultant vector looks like this. This is going to be your negative vector or the resultant velocity vector, I can say. Maybe your game object is moving in this direction. If you flip the velocity vector, it will move in this direction. So negate, if you are using with the velocity vector, guys, it will negate both the components. It will negate both the components of that vector. If you want to negate the individual components, then you have to publicly or directly access them. Velocity.x is equal to minus velocity.x. Also you can do velocity.x. If you do, only the x component is going to be negated. Y component will be same. So individually also you can do it. I am telling you. You need not to flip both the components. If you want to flip both the components, then you have to use the minus operator. If you want individually flip, then you have to perform the operation like this. Understanding? If you perform this operation, only the x component will be flipped, not the y component. So this is how you can use the negation operator to negate and flip and move your game object in any direction. Anytime you can flip the velocity vector to move in any direction. So I think for this tutorial, this much is enough, guys. Keep experimenting, keep learning, keep coding. See you in the next tutorial with some other things. Thank you, guys. Thank you very much.